This is the video demonstration for the Stepper motor software for the Embedded Controller Board project, Semester 3, Project 1. This is my hookup. I have it connected from port A going to a L23D H-bridge, which is driving the stepper motor right there. And yeah, it's just a basic setup, just like we had for our process control lab. You know, easy peasy, nothing to it. All right. So right now we're looking at my interrupt. Now it mostly triggers every millisecond. I have an ISR counter that you can change whenever you want. So you can trigger 1 millisecond to 10 milliseconds, whatever you want to change the period, the triggering value, to change the, when you're going to step and do the stepping. Um, yeah, everything's controlled there in the interrupt. A lot of the code has changed, so keep in mind I have done a lot of revisions to it already from this video. But here's my main function, the start stepping. You could step in any direction you want, clockwise, counterclockwise, with the step size you want. There's a lot of verification and checking on that. You can do it from the time per revolution. So, to do one revolution, that's how fast you're going to go. So usually like 10 milliseconds to do one, or 5. If it's going to be continuously rotating. If not, you're going to be, you want to enter the number of steps you want to rotate. We're going to go down here, and I'm going to show you I'm going to demo my first thing for you. So what we're going to do is we're going to do half stepping counterclockwise with the 10-second per revolution. It's going to be continuous, and we'll just watch it here for a bit. So you can kind of see it takes its time, slowly getting there. So I'm going to set up for the second one. We can see that it's working. Alright, so the next one we're going to do half stepping clockwise. We're going to go about 5 seconds per revolution, and it's not going to be continuous, and we're just going to do one revolution. So just keep in mind where the position is starting, and get ready to watch it do one revolution.
In the clockwise direction, and this will not be continuous. I will be doing one revolution, 192 steps, and the half stepping.
Just a sec, here we go. So it's doing its one revolution in 5 seconds. Boom. And there you go. And so the final one I'm going to show you is full stepping clockwise. We're going to do a step of 2 seconds. It's not going to be continuous, and we're going to do 5 revolutions. So this one's going to be a little fast. I've noticed the timing's not perfect for this one, but it is as close as I can get it. It's rough. So I'm just going to get it going here. Yeah, you can see that it's going to rotate clockwise. There we go. It's doing it pretty fast. And that is my final demonstration. So I demonstrated that I can do half stepping, full stepping. You really couldn't tell in this, but if you look at my code, you'll see that I'm doing either or. I take in consideration if it's half or full to do the speed. Also, too, I have put in some functionality to get the position of the stepper motor. The thing is, in order to do that, you have to kind of set the home position, because you got to know from where from here to there, how far I've gone. That's how you know the position. So I have put in that so you can set the position wherever you are in the stepper motor, and then from there it will figure out it'll figure out the distance, the number of steps between the home position and the current position, and it would return the value. If it's going clockwise, it will return a positive value. If it's going counterclockwise, it returns a negative value. And that's how I do it. And if the thing does a full revolution, as soon as it gets to its home position, it resets again. So it's just an easy way to keep track of the position and all that. Um, yeah, that's about it. You can see through my code, I've done some commenting in that. I have done a big revision on my code just to make it more robust, less code, less, you know better. I have put some functions in like stepper forward, which just which actually just goes one step forward, but it starts the whole stepping process and not continues. And step backwards, you just go the other way. And yeah, that's about it. Nothing much. This pretty much gives the full functionalities for someone to control the stepper motor and figure out where it's going and the current position. So that is it. And just let me know if there's anything else, any other questions. Let me know through email. And you got my code, so